This is question 4 from the third CSAT sample paper. In this question we're told a hiker starts walking at t equals 0 hours and finishes at t equals 1 hour. And we're told their velocity as a function of time is cos of t times pi over 2 in kilometres per hour. So it's not explicit, but it looks like we're measuring t in hours here because we start at 0 and end at 1. And we're asked at what time do they reach halfway to the destination, where the destination is where they are after 1 hour. So if you want to have a go at this question yourself, pause the video now. Okay, so part of what makes this difficult to start with is we're asked when they reach the halfway point, so in terms of having travelled half the distance, but we're not directly given any information about distance, so we're going to have to find out about that from what we are given. So we start at t equals 0, we reach some location at t equals 1, and we don't know how far this is, but we do know that we want to reach halfway. And if the speed was constant, this would be fine because it would just be at half the time, but the speed is changing, so we don't know at what time we reach halfway. We need to figure out how quickly we're covering distance, that's going to be connected to this, and also know about the total distance we're travelling so we can find out what half that distance is. So how can we relate what we have to distance? Well, we're given velocity, and velocity is ds by dt, where, okay, I've been calling this s for distance. It's really displacement because velocity can be positive or negative, and so can displacement. But actually, if we look at this carefully, when t is 0, we've got cos of 0, which is 1, so it's positive at t equals 0. And then when t is equal to 1, we have cos of pi by 2, which is 0. And the times we're looking at are between here and here, so the numbers between 0 and 1. If we plug this into here, we get cos of something between 0 and pi by 2. So this is always going to be positive, except at t equals 1 when it's exactly 0. So that means we can basically treat this as a distance instead of a displacement. Okay, so given this, what can we do? Well, we want to find s, so we basically want to integrate this with respect to time, and that's fine because our expression for the speed is in terms of time. So we can write ds by dt is cos of, I've written it as pi by 2 times t now, and that's because if we have a constant times t, we can undo the chain rule when we integrate. So if we integrate this, I'm writing it as s of t, because I'm treating it as a function of time. Well, if we just integrated cos, we'd get sine of pi by 2 times t, but because we've got this pi by 2 here, we need to undo the chain rule, so we need to divide by pi by 2, because when we differentiate this, we're going to multiply by pi by 2 because of the chain rule to give us this. And also we need to remember our plus c. Although in fact, if we want to get rid of this c, it's quite easy, because remember we were told that we started at t equals 0, and that means at t equals 0, sorry, if I just rearrange this to simplify this fraction, when t is 0, we have, we're looking at s of 0, because it's a function of time, and that's equal to 0 because we've just started. And if I plug in t equals 0 in here, I get sine of 0 is 0, so this whole term disappears and we just have c. So that means from here we want c to be 0, and that means that s of t is just this part, 2 over pi times sine of t pi over 2, or you could write it as pi by 2 times t again. Just quickly, there is an alternative way to do this, which is if we think about velocity as a function of time, we just said it's starting at 1, and then when t is equal to 1 we have cos of pi by 2, which is 0, so the velocity looks like this. It's just like the first part of the cos curve, and the distance is just the area under that curve, which is the integral between, well, I've written 0 and 1 for s of 1, so if we want the total distance covered, that would be the whole of this area, but if we want s of t, it would just be from the integral from 0 up to the time t. And that gives us exactly the same as this, except because it's a definite integral starting at 0, we get rid of the plus c from the very beginning. Okay, so now we have this, let's look at finding the time to get to halfway. Okay, so here's our value for our expression for the distance, and what's going on, we want to know the time to get to half of this distance. Well, we can easily find this distance because it's the distance we've travelled after 1 hour. So if we plug in t equals 1, what do we get? We have sine of pi by 2, which is just 1. So that means we've got 2 over pi times 1 is just 2 over pi. So that means this total distance is 2 over pi. And we want the time to get to halfway. Well, how far is that? It's just going to be half of this. So we want the value of t when we're at half of this distance, which is just 1 over pi. Alternatively, if we want the time at half of this, and half of this was when sine was equal to 1, we want the time when sine is equal to a half. So we want sine of t pi by 2 to be equal to a half. We just have to be careful because this has lots of solutions because it's a sine function, so we in particular want the value of t between 0 and 1. Well, when is sine a half? They actually give you a hint in the paper, but it's a hint you should know anyway. Sine is a half when the value inside is pi by 6, so sine of pi by 6 is a half. And that means we want t of pi by 2 to be pi by 6. Okay, there are other values that work, like 5 pi by 6 and so on, but it's pretty clear we want the smallest positive value so that we end up in this range. And then if we want to solve this for t, we can just cancel the pi's, multiply both sides by 2, and we get t is 1/3. This is measured in hours, remember, which is what they asked for, so you could write 20 minutes, but in terms of hours it's 1/3.